Hello, my name is Mikhail Dvorkin. I am 2007 ICPC Gold Medalist and Kotlin enthusiast. In this short video, I will be using Kotlin to solve a sample algorithmic problem that appears sometimes on coding interviews. This problem will concern finding dictionary words inside the rectangle filled with letters. Let's go to an IntelliJ IDEA window to discuss the problem and solve it in Kotlin. First of all, I'd like to thank Solontus_ and Lalit Kundu for bringing up this problem on different websites. So the problem is we have a rectangle filled with English letters and a set of words that we will call dictionary. And the question is, which of these words can be read in this rectangle if we are allowed to read horizontally or vertically and turn 90 degrees as many times as we want. For example, in this rectangle, we can read the word Kotlin or fun or file according to these rules. Let's hard code the rectangle with letters into our program. So this will be a row string with all these tabs and line feeds that we will deal with later. And the dictionary will be also stored as a row string that needs some processing as well. The rectangle row string has all these tabs and line feeds, so let's first remove the tabs by trimming all the indentation of the string. And now we have a single string with letters and line feeds, so let's split the string with a line feed character to receive not a single string, but a list of strings that are horizontal lines of the original rectangle. We can print the resulting variable to make sure we got our trimming right. And now for the dictionary line, let's make sure it's uppercase, just as all the letters in the original rectangle. And now with this uppercase single string, we can split it by a comma and a space to receive the list of single words of the dictionary. Actually, knowing that I want a lookup operation in this data structure to be quick, I can make this a set. Now let's actually code the method that is going to do the main work. I propose a recursive implementation over here, so let's discuss the signature of our method. For now, let it receive the coordinates of the cell that it is currently processing, but we will update the signature with some more arguments later. When we enter an instance of this recursive method, we are standing in the cell with coordinates x and y, and in general case, we want to make a recursive call into each of the 4 neighbors of this cell. How do we organize the iteration over all 4 neighbors of this cell? Well, I propose a list of vectors that show the directions towards all the 4 possible neighbors. In this list, I will be using Kotlin pairs to store the direction vectors. Now, in the recursive call, I can iterate over all the possible shift vectors, and in this for loop, I will be using multiple variable assignment to introduce 2 variables, the x shift towards the new neighbor and the y shift. With these 2 variables, I can calculate the coordinates of the next cell that I will visit in the upcoming recursive call. We have the new x coordinate and the new y coordinate, but these 2 coordinates can show outside the rectangle, in which case I want to ignore this iteration of the for loop as this shift vector is useless. Also, I definitely want to know the letter that is located in these new coordinates if they indeed show inside the rectangle. So let me write the code that does these 2 things simultaneously. I could have written a simple code that makes a direct access to the 2-dimensional array by the y coordinate and then by the x coordinate. But this code raises an exception in case a y coordinate or an x coordinate goes outside the rectangle. So let me rather use nullable objects here that Kotlin handles so nicely. And instead of taking the horizontal line with such index, I will rather use the getAllNull method that will give me the horizontal line with such index or null in case this index is invalid. For this object, I want to do something only if this object is not null. So I put a question mark here, and then I apply the same method to receive the value in the certain index or null if this index is invalid. This object is the letter located in the desired coordinates or null if at any point the y-coordinate or the x-coordinate was pointing outside the rectangle, in which case I want to disregard the entire iteration of the for loop, which is exactly what a continue operator does. So if I have reached this point of code, then I didn't run the continue operator, and therefore my coordinates are showing to the actual cell and not outside the rectangle. So I can make a recursive call to these new coordinates. So over here I make a recursive call to the new cell that I'm sure is not a place outside the rectangle. However, this resulting code is an awful example of the infinite recursion, because each instance of my method always runs several other instances of the same method for the neighboring cells, and they do the same recursively, and so on and so on and so on. So we need to stop our recursion at some condition. In order to do this, let's change the signature of our method so that it receives the word that has been already read during the previous recursive calls. With this word, we can stop the recursion if this word is not a prefix of any word in the dictionary. We need to pre-calculate before the recursion the set of all the prefixes of all the words in the dictionary. Let's take our dictionary, and I could have used the map method to receive the list of lists of all the prefixes of the words in the dictionary. But what I actually need is the concatenation of such lists. So instead of the map method, I will use the flat map method that will do exactly the thing. Inside this flat map method, I want to receive the collection of all the prefixes of the given word. So let me introduce the word variable that I will be working with. And here I need to construct a collection with its prefixes. It will be a list, and the length of this list will be the length of my word plus 1. And for each index, I want to generate the prefix of my word with the corresponding length. So from my word, I take the corresponding number of letters. And once again, since I want the lookup operation to work quickly, this overall collection should be rather taken as a set, not a list. Now let's get back to the recursive method. In case the already read word is not a prefix of any valid word in the dictionary, just disregard the entire recursive call. And if the current read word is exactly a word from the dictionary, let's print it to the answer. And the recursive call to the neighboring cell should also pass the correct argument to the method. So it will be the already read word plus the letter that we have seen in the new cell. Now we are ready to make a call of the recursive method for each cell of the rectangle. In order to do this, we iterate over all the possible values of y-coordinate, and instead of writing the specific lower and upper bounds, I'd rather write the indices of the rectangle, because this is exactly the values for y that I want to iterate over, and I will not make a mistake by +1 or -1 in such code. Now, for the x coordinate, let me also write some code that will be safe from +1 or -1 mistakes. So these are the indices of the horizontal line, for example, number 0. And for each y and for each x, I make a call to the method search with these two coordinates, and the word that I start with is the word consisting of a single letter in these coordinates, passed as a string. These for loops will run the recursive search from each starting point, and these recursive searches will print all the found words to the output. So let's run this code to find all the words in our rectangle. And we see that our rectangle contains all the words from the dictionary except for the word null. The basic problem is solved, but the important exercise yet to be done is to forbid ourselves from coming to the same cell several times, because it's a very natural thing to disallow, and our code still allows such behavior. So I leave it as an exercise for you, or probably we will do this in some other later video. Thank you for watching this video. Have fun using Kotlin and other programming languages, and good luck in your careers. Bye.